In this chapter, we will continue shaping this rim without tessellating the geometry to create higher level of detail. Although, at this point, we are good to go on this path. The aim of this tutorial is to show you the most commonly technique used in creating mid or lower poly count assets for games. The only limitation is the number of polygons to deal with. When it comes to designing with polygons, it is preferable to work with the lowest number. This will keep things manageable and reduce both effort and designing time. In the previous chapter, we have created these gaps inside the rim spokes without adding any supportive loops. This is not the right approach in designing with polygons. To show you how to plan your modeling approach correctly in targeting a clean topology that will suit your game requirements and future updates when required. The right approach to create a hole in the geometry is to add a supportive loop first, then create the hole in the surface. I need to increase the scale of the selection, since the supportive loops will be located inside each group of the selected polygons. You do not need to follow this if you properly align the edges to the reference template that was provided in the previous chapter. Once we have a clean topology, we can use the Turbo Smooth modifier in order to achieve higher level of detail if needed. Of course, we need to add more supportive loops, detach elements, and properly prepare the base for a better result. All these steps of this technique are fully explained in the previous tutorial. In this tutorial, we will create the level of details without using the Turbo Smooth tessellation. I would like to offset this supportive loop away from the edge. You have 30 seconds to think of a better solution. The solution is to select the polygon's ring loop, then use the Insert tool to add another one at the desired location, then remove the old loop. In order to shape the tire mounting area. Use the loop tools to bring the inside loops closer to the edges. With view as reference, in the coordinate system, scale the selected loops 96% to bring them inward, as shown. As for the inside of the rim, select the back border. Hold Shift, then move to extend the border on the negative x-axis. Extend the selection. Use the Scale tool to scale down the original loop, as shown. Later, we will snap each opposite vertices to close the gap. Next, I am going to arrange the edges on the rim's mounting area, mostly with the help of the Relax tool. Since we will create holes and bolts for this rim, we need at least one supportive loop in this area. The mounting holes will be located in the highlighted polygons. The easiest way to close the gap of the rim interior is by bringing the two borders of the gap closer to each other. Then use the Weld tool with 1 mm distance to weld all vertices in that range. use the Snap tool to overlap and arrange other opposite vertices that were not in the weld range. Use the Cut tool to add new vertices to those without opposites. Finally, use the Weld tool, again, with 1 mm weld distance, to weld any overlapped vertices. Then detach elements, as shown. Assign one smoothing group to each element. We shall continue this in the next chapter.